Good afternoon, everyone. All right, so this is Network Telemetry with Event-Driven Ansible. So there was another title on there, so some people were a bit confused. But yeah, that's what we're going to be talking about today. So I've got these two gentlemen here with me we've done some cool work together from a Red Hat and Arista perspective. Do you guys want to introduce yourselves? Do you want to come onto stage?
Oh, sure.
Yeah, I figured we just...
So I'm Nuno. I'm a technical marketing manager in the Ansible BU, and I focus on Event-Driven Ansible. And you guys?
Yeah, so I'm Julio Perez. I'm a solutions engineer with Arista. So it's a pleasure to be here. It's a pleasure to be speaking in front of you guys. It's an amazing crowd. So thank you for being here.
I'm Dan Hertzberg, and I'm a technical marketing engineer with Arista Networks, and definitely excited to talk about Event-Driven Ansible today.
Cool, thanks. So I'm going to go through some Event-Driven Ansible fundamentals. I'm sure some of you have already seen this. You've probably heard it already. We seem to be talking quite a bit about it. And then we're going to hand over to these guys from Arista, right, who already took event-driven pretty quickly and pretty soon as we started to bring it out from Ansible Fest and started working with it, right? So we do have a lab which is happening today, which kind of focuses on this. But you're going to see what we're talking about from an Arista perspective is we're talking about using things like Cloud Vision and their platform and kind of what their demo kind of incorporates is their traditional type of topologies and their working environments, their tool sets, and how they used Event-Driven Ansible to obviously accommodate, the solutions and all the situations that they have, right? So let's get started. I'm going to start diving into event-driven, and then we'll hand over to these guys, and we can see the magic and see what's going on. All right, so from an event-driven perspective, we all know how this stuff works. We have a technical issue in our company. What happens typically? How does it, what is the toil that we go through every single day? I have an issue, I log a ticket. That ticket gets, allocated to a team or an engineer. They look at it, they're not too sure, they escalate. Eventually, sometimes you get to the point where we can even have the vendor that gets involved to try and assist. Now, eventually, we do have a solution in most cases, right? So that's cool, but what we don't get is this takes a lot of time. So we get to that situation where going through this up and down situation, login calls, escalating, everything takes a while. So this is a problem. And especially it's a problem if, your teams are asleep or this is something that you're not really, you're not on the clock or anything like that. So where does event-driven fit in? Now, event-driven is what we kind of call this an advanced automation process or an advanced type of automation. And what we can do is we cut all of that out. So instead of having to have this whole typical process of logging a ticket and then, going through that process, we can already predefine actions that we want. We can predefine things like troubleshooting techniques. We can even go to the point of, just getting event-driven Ansible to focus on observation. What I learned, at least from working around NetOps and with networks, is network guys don't like automated fixes. So every time I spoke to a network guy and say, yeah, but there's a BGP error, we can just get EDA to fix it, it's not a problem. I go, no, we're not doing that. So I think observation is probably a little bit more relevant for that. So imagine something goes out, something goes wrong, could be BGP, could be anything that goes wrong, and when you get to work the next day, all the troubleshooting has already been done for you. There's already a service ticket with all the relevant information, etc. And you just need to go, cool, it's this issue, we go and we fix it, right? So that's what event-driven could typically do. So event-driven works on three components, and we like to say that we receive content, so we receive events. These events, we always talk about events coming from intelligent sources. So event-driven doesn't work as an intelligent source, right? It doesn't have an intelligent source. It looks for like an observation tool or something like that. We expect these tools to provide us the relevant information. From there, we can take that into event-driven, and event-driven can kind of go through conditionals and has like a decision engine that's built into it that it can then decide what we need to do based on the logic that you apply. And then lastly, the responding, or what we call the action, is typically when something goes wrong, we go through the conditions, at the end of that condition, it's been met. From there, run this action. Whether it's a remediation or an observation action or whatever, that doesn't matter. It just gives us the ability to act on what we've seen. So these components or these ideas all come down to sources, rules, and actions. Now, the sources we're going to dive into, we have a number of different sources. So these source plugins that we call them, this is where we get our intelligent event information from. And these source plugins at the moment, for example, we have things like generic webhooks, we have Kafka, we have some file system watches, we have a number of community-based plugins that you can use. We also have partner plugins, right? So, the guys at Arista here, they also built a partner plugin which they released to the community, which is actually quite cool, it's quite powerful. But we also have, other partners like Dynatrace, for example, who are busy building one. And we have a lot of this integration with our partners, which is one of the really cool things, right? So we're going to have a look at how those sources are or how they work. From the rules perspective, again, this is all conditional stuff. We're always talking about this as a giant if-else-then type of situation. So as the events come through, it goes down that list of conditions, and based on what it meets, it will then obviously go through. As soon as an event has been met, that event is basically removed from the event queue, and we go and we deal with it. So with event-driven, we also have ways of actually gathering output from playbooks or what the results from the actions are, so that we can feed that back into event-driven for, perhaps you want to have another condition to trigger after that. So imagine something goes wrong and you get an automated, remediation of restoring a config to something. Then what happens if that fails? Well, we could technically take that failed response out of that playbook, feed it back into event-driven, and escalate the issue to another ticket logging system or anything else, further action that you want. Now the actions, I keep talking about actions. Actions are what we're ultimately going to be able to do. So you can go and you can run a playbook, you can trigger a template, you can go and even trigger a module. What we're able to also do is we can set facts, we can also load facts. So you could have a file full of facts in terms of what you want to use for Ansible, and you could use that as an actual action. You could also use that to trigger further events. So there's a lot of flexibility in terms of this mechanism. So now the key thing with event-driven is we now have a new component within Ansible, right? This is the Ansible rulebook. So everyone's familiar with an Ansible playbook, but the rulebook is a little bit different. Where it's not different is it's also based in YAML, so it's really easy to build. It's fairly understandable in terms of what we're doing. But you can see that we define the sources, we define the rules, and ultimately we define an action per rule once it gets met. So this is really easy in terms of how we can build this and we can work with it. And the one key thing with the rulebook is that we'll touch on a little bit later, that it has a key difference between the playbook. So when we go and we trigger a playbook, what happens? You go from top to bottom and you run all the tasks, and once you've done that, you're out. You're done. With rulebook, it's not that way. So when you trigger a rulebook, what it does is it stays in the observation and evaluation phase. It's constantly listening to that source that you've defined. So you could have something come in, it can be evaluated, it can then go and say, well, the rules engine says I need to trigger this template or I need to trigger this rulebook. It will trigger the playbook will go do what it does, it will exit and carries on. But Ansible rulebook is always sitting there listening for the next event. So it's constantly capturing these events and filtering these events out. The only time that this will actually shut down is when it gets a shutdown event. So we actually have a shutdown event which will close it off. Okay. But otherwise, this continues to run, continues to listen to those sources, and issues out actions based on what happens. Right, so this is a very basic diagram of how it looks, right? So we have event sources, so you can see some of them there, Alert Manager, Dynatrace, etc. These are your typical observation like examples. And we have a Kafka message queue, which is optional. So I typically think that, or I typically say that Kafka is a bit of a cheat, because if you don't have a tool that's going to give you, some event information via webhook, etc., you can always go back to a messaging queue. right? So that gives you the flexibility, being able to have multiple topics or multiple queues where you're getting maybe application information or you're getting infrastructure information, and then all you need to do is actually listen to that queue, and from there you can get event-driven to actually trigger based on those messages in the queue. So it's actually a really easy way to work with event-driven, and I generally start off with this. But yeah, for me, it's a bit of a cheat because it's kind of like a save all. So once these events come through, whether they're coming through messaging queue or just direct through a plugin from an event source, we go through a rules engine. That rules engine goes through its conditionals, and then ultimately we have our automation that takes place. So these are some of the plugins that are available and some of the plugins that will be available in June. And you can see that, like Arista, for example, is marked for validated content. We have, things like Red Hat Insights already we can work with through stock standard webhooks. But otherwise, we have, things like Azure Service Bus, which is quite cool. We are waiting for all of the event sources for the cloud providers, right? So AWS, etc. This will allow us to then listen to cloud events, and based on those cloud events, we can then trigger automation to do whatever we want, okay, whatever we need. Most people that I've seen so far, we tend to work a lot with the webhooks, with Kafka. We've got obviously the Kubernetes plugin and Prometheus. The one thing about the webhook that's important is the webhook, if you're working with a webhook with automation platform, we all know what happens. You trigger the webhook, it goes and triggers a template. There's not much else to it. But with event-driven, what happens is we're actually listening to the full payload. So we get the full payload of that event, and based on the payload, we can go and use all those JSON objects for other conditionals inside. So like if you just used like a GitOps example, you could now filter every webhook for, is it a PR, is it a commit, is the main branch been affected, etc. You could use all of that as actual triggers inside of an event-driven Ansible rulebook, right? So that's quite cool, that's quite flexible. Cool, so that's a little brief around event-driven. So I'm now going to hand over to these guys here. These are the experts around networks. So take it away, guys.
Yeah, I don't know about expert, but we'll see what's like after this talk. Just in general, how many people here are network people? Come from network experiences? Oh, cool, awesome. Who considers himself like a developer for the most part? Anybody in the room here? Cool, awesome. Here for EDA? Anyone just in general here for EDA? Cool, this will be a little bit for everybody. But in general with EDA, like we've had a lot of fun like developing this. So we're gonna have two parts of this presentation. The first part will be more or less like kind of how we developed our plugin. Well, it's really using the NATS message pub sub bus plugin portion of it. And the second portion will be an actual demo of what we're pitching the customers to use EDA for with a couple of our platforms. But in general, this is something we believe in. This is something we really had fun with. We like Nuno said, this is something that actually reacts to events, which is good. It's event-driven, hence the name of it. Because for so long, you've kind of had the AWX and tower sort of thing, where a human being would actually have to kick off via JSON into an AWX or a tower job, where this is a little bit different. You could pull in your own custom plugins and inputs and so forth, which make it really, really nice and flexible. So we'll talk about the timeline for development. This will mainly be from like our experience for the most part. Red Hat emails us probably back in, I'd say, November of last year, asking for a little bit of help with this sort of thing about EDA. And I don't think it was called EDA at that point. I think it was just called like Rulebook. Was that the name of it? Yeah, Rulebook. And kind of look at some of the docs, took a look at it, was really fascinated with it. Because a lot of the network automation platforms that have been out there for some time haven't had quite the modules that Red Hat has with Ansible. Like you could realistically find modules for just about anything. If not, you can create them. Some of the previous platforms I've worked with, and wholly I've worked with network configuration, they've had this like sort of event-driven thing where a thing would happen on a message bus, a thing would happen on a webhook, and you could actually queue these things off. And just having just a human operate to do it was kind of cumbersome for most people. I wanted more of an automated platform. So they gave us kind of a product dump in December, and I think literally we turned around a plugin in like less than 24 hours, which was like really cool. Our group, the group Julio and I work in, it's more of a group of work with integration pieces into Arista. So we're like, I wouldn't consider myself a developer. I don't think you would consider yourself a developer really either, but we work with a lot of newer type of platforms and we're able to code a little bit. Python's not my everyday thing, but the way the setup within EDA was really simplistic. Since they have their own collection, I think these slides would be distributed. But the collections, we were just able to look at them and just kind of take from that and say, hey, any Python async we push into the EDA process, it'll just key off of that and we can make things work. So it was incredibly simplistic. Now, what we did was we used NATS. Is anyone familiar with NATS? Everyone heard of NATS in the room? It's not network address translation, so don't be afraid if you're a network person. I don't even know what it really stands for, but a lot of people hear the word NAT and they just suddenly just like it's a I don't know, but it's very similar to Kafka. So if you use the pub sub bus, it does a very similar thing, but we use it a lot internally at Arista because it's such a small binary and server. Like the Docker image is something like 30 megs, and it doesn't require any type of like zookeeper and everything else, something like a Kafka would use. But we're able to take all these events that happen on the network, things like BGP, things like interfaces going down, anything in the control plane that actually breaks, we take that and we push that with this plugin into the NATS pub sub bus, which is really cool. So it's not pull based. So if anyone's familiar with SNMP, I think SNMP is a necessary evil that a lot of people run just because it's kind of operates most networks today. And this is on nats.io. So Julio and I will be around for quite some time today, even after this. There's a 3 o'clock to, I think, 4 something or other demo that actually uses the demo that we helped Red Hat run. So it kind of looks like this. This is the way we push the demo, and it was pretty easy for us, like I said, to do. Like we turned it around in like less than a day. But the whole idea is that there's a streaming client. It's called GNMIC. If you're unfamiliar with that, it's able to take all the streaming state from a switch, take that streaming state and push that into the pub sub bus. Once anything happens on the pub sub bus, the EDA integration piece we wrote will just read off the pub sub bus. Very similar to Kafka, so if you're totally unfamiliar with this, think of it like the subscriber sits and just listens to a queue on NATS, and when something happens, it gets pushed into the NATS subject, and then you can key off of that. And the specific keys are things like interfaces going down, BGP going down, and whatever else. And then like I said, these slides are being distributed. The little gopher icon is the NAT subscriber that was written in Go just for like a client type of situation. All right. So we'll talk about what we've been using a lot with our customers, and a couple customers trying this in production and so forth. And more or less, this will be the demo we're going to provide today as well. And what we're trying to do with a lot of people is say, hey, before you push a change, before you make something go into maintenance mode, before you do a code upgrade, you should do something more or less to the event of kind of letting the masses know. Because I'm sure most people live that YOLO life, right? Where it's like, push the button, make it work, and not really tell anybody. But this is going to be doing something on the network and then telling everyone via like Slack and then creating an ITSM ticket, doing it all in a very automated fashion. Because when we first talked about EDA, we talked about, it'd be great to say, something broken on a network, automatically fix it. And I think most network people are going to say, it's a little sketchy to do that sort of thing. Like they'd like to actually be able to prove it and not really be into the self-remediation type of aspect. If you're totally unfamiliar with Arista and the way we work, basically what we do is we take the whole state of the network. When I say the whole state, I'm talking like distributed state of every single switch. We push it into our main management platform called CloudVision Portal. But we take everything, we bidirectionally stream it. So I say bidirectionally stream it, I mean as things actually change, we take all the config, all the temperature sensors, BGP neighbors, interfaces, pretty much, we even take S-flow data. So like anything that really happens on the switch gets pushed out the CloudVision Portal via gRPC, which is a streaming API. So this CloudVision Portal, this management platform we use that we're going to demo this today, it has everything. Like it basically has everything that goes on within the network, whether it's somewhat of data plane and control plane aspect. It's got all the stuff, which allows us to do really cool stuff. So within CloudVision Portal, like we're able to actually see like anomalies that happen, real-time topology views. So if you were to cable, uncable, cable, uncable, you could actually see it in real time. Our switches do provide hitless patching. So if you were to do something like do a code upgrade, we could do it to the point where it's a 50 millisecond blip, which is like pretty nice. Roll back the whole network, anomaly detection, it's all there because we have all the data. So in this demo, here's what everything's going to be set up. It's a leaf spine network. I think most people who are network people are used to what a leaf spine network is. So leaf-spine network is effectively where you care about east-west traffic, moving that traffic really quick, bidirectionally from east side, hence the name east-west. And everything's meshed together via BGP. So leaf and spine, on the underlay at least, are connected via BGP for the control plane method. And we have a thing called maintenance mode, and it's a well-known RFC. It's called G-shut. So what's going to happen is, Julio will go into it a little bit, but a human being is going to go into our CloudVision portal platform and say, I want a device to be in maintenance mode. When you put a device in maintenance mode, what it says is all the routes going to the spines and vice versa, they're no good anymore. The device is in maintenance mode, don't send me any traffic. And you could even get on to the point where it shuts down all the interfaces below it and the MLAG peers and so forth. But basically it puts the device in maintenance mode so you're able to upgrade code, make some changes, do something in which you wouldn't want to do live running on a network. So CloudVision Portal is a really nice setup for EDA, and the reason why is because we have all the state. And we have all the state for all these devices. We're able to actually send off webhooks if something goes wrong. And if something goes in maintenance mode or something breaks and so forth, and we'll get into the demo here in a little bit. But basically anything within CloudVision Portal that we can key off of any type of data, we'll talk about it here in a second, we could send off into the EDA server, which could then run your Ansible playbooks. So I'll hand off to Julio to talk through the demo.
Cool. Thank you, Dan. Okay, so here on the top left, we see a client. And again, like Dan mentioned, we're going to set a device into maintenance mode, whether we're doing some kind of troubleshooting or maybe an upgrade, and we don't want any traffic to go to a specific leaf. In this case, that's going to go through CloudVision, which is then going to send a webhook to the EDA server or the node running EDA, which then we can trigger additional playbooks to run sort of actions for us, whether that's creating ServiceNow tickets, Slack notifications for the team. Something else you could think of that Nuno mentioned before was that let's say you did receive an event where something was down, you could have EDA read those events to then automatically trigger your troubleshooting runbook, right? You manually already run some kind of troubleshooting runbooks like show IBGP summary or show IP interface brief. You could have EDA essentially run those for you and just post them to a Slack room. So again, sort of in that case, even speeding up troubleshooting, right? In this case, this will be a simplistic version of that, of just setting a device into maintenance mode versus doing the troubleshooting tasks. This is just a view from the CloudVision portal. Here on the right is just examples that are pre-canned for creating a webhook. In this case, we're setting a receiver name of EDA webhook, but we're sending everything. So everything that CloudVision receives as an event will be sent to the EDA server. So again, it's lab environment, that's our setup to send everything. This is an example of an event from CVP in JSON format. In this case, you can tell probably by the 3 dots, this payload is actually incredibly long. It's just trimmed down for this slide. But here we can see that we have an alert, a device is in maintenance mode, and then within the labels, we can see that we have a device host name. So again, very useful because we can tell what device was modified and what was the event. And again, at the bottom there, status is firing, so something is executing. This is an example of the runbook that is used within EDA. So for example, we're on our EDA server, we initialize this, and then it's always listening. Here at the top, you can see the sources perspective, and we're using the EDA Alert Manager source, which essentially is just spinning up a web server on port 5000. It's listening for any requests that come in. Here, you might see a filter. The reason we use a filter is because we're actually keying off of specific keys in that JSON payload. But again, it's incredibly long, and there's just certain keys we just didn't want to see in the payload when we build or when we filter on the events. Again, that's more for just to clean up the data. If you had a very small JSON payload, you wouldn't have to exclude keys, but ours was pretty extensive because there's just a lot of data in there. Okay, I'm going to skip rules because we actually have a rule section here coming up. So once EDA receives some type of event, we have a set of rules which then have conditions of something has to match for me to perform an action. So in this case, we have a condition called all, so it needs to match all of these statements. In this case, we did it as a one-liner with an and statement, so they both have to be true. In this case, we're looking for event.alert .status equals firing, which you can see here at the bottom, status is firing, and then the alerts.labels.event type is device maintenance mode. So if EDA sees this JSON payload come in, it will match this condition, which can then execute some kind of action. Okay, so that is the condition and the rule. Within the rule, now we have an action. So in this case, this is a run playbook action. So fairly simplistic, we're going to run a playbook. In this case, we named it set match. It could be whatever you like. Pretty interesting here is because it's EDA, it's Ansible. You already have access to all of the Ansible collections, any of the playbooks you already run. You can still leverage all of that within EDA. So we think that that's a very powerful thing to use. And in this case, this example, we're using Snow and Slack. So just the Snow and Slack collections. In this case, this playbook here is trimmed down again just to fit, but in the demo, you'll see the entire task output and the build of the task. So in this case, we have a first step to just collect some facts from CVP using our own CVP collection. And then we do a local action, which is just saving the configuration of this node that was impacted. So in this example, I think it was leaf 1. So just save the config off to some directory. Then we create the ServiceNow incident. In this case, our ServiceNow incident was pre-populated with our configuration items. So we can tie that ticket to that specific configuration item. And then the final output, which would be notify the team in some kind of Slack channel that something is going on in the network. Right? So it's kind of more of like an awareness thing. Something I forgot to mention actually is that within EDA, once these playbooks are triggered, there's actually data available to you. So in this case, we're setting a variable called device hostname, but we're registering that from EDA output. So in this case, you can see it's Ansible_EDA.event.alert, labels, hostname. Pretty extensive, but useful that you can use data from EDA within your Ansible playbooks. So long-winded, but very powerful. Okay, that is all. Dan's going to take over for a little bit of a video demo, so thank you.
Yeah, I got it. I might be able to figure out how to work videos. Yeah, before we pop the video, let me just an explainer once again about what this demo does. So you see upper left-hand corner, you see the client, this beautiful Visio thing that says client. That person's going to go ahead and go into CloudVision and say, I want to set this device to maintenance mode. Maintenance mode sends a BGP community called gshut. So imagine a switch with a bunch of servers connected to it that someone wants to do a code upgrade or just any level of maintenance. You're going to want to shut that down, not almost like gracefully. So if you're used to compare it to like a VMware, you want to put an ESXi node into maintenance mode, like evacuate all the guests, but it's still actually working from a management perspective. Very similar ideology. Once that happens, our CloudVision portal sends the webhook over to the server that runs EDA. And that's where kind of the magic happens. The playbook will go back and use our APIs on CloudVision to actually leverage that device's running configuration, pull that back, throw it in a ServiceNow ITSM ticket, and then add a little bit of like verbosity, like, hey, like, here is some information about this device in CloudVision. You can click on it. It'll give you historical information on it. And also as well, it'll kind of upload into Slack a small what is it? It's D2, right? It's
D2 lang.
Yeah, D2 lang of a picture of the network topology and kind of alert everyone within your organization if Slack is your thing. It doesn't have to be Slack, but it could really be anything. It's just what we use a lot internally. All right. So hopefully I can work a video. Is that good enough here? Okay, so what we're going to do first is we're going to run the rulebook. I think everyone can see that. But use the Ansible rulebook binary if you're not used to EDA. It's a totally different binary than most people are used to with Ansible-playbook. But you're going to run Ansible rulebook. You're going to say where the rulebook is located. So the CVP alerts, kind of like what Julio showed, the local directory, and then you're going to point to where the inventory is. And if you want to, you could do verbose. Just pick verbose because it has a lot of information on it. But run that here at the bottom. And we can see it is actually running and waiting and expecting for a thing to happen. And that thing is the webhook with all the criteria with status firing and so forth. So if we pop over here, I'm going to kind of drag this video because we used a lot of this for internal use as well. We can see all our devices within CloudVision Portal, and we can make what's called a change control. You can see on the bottom through me messing around through this demo, all the failed and past changes that we personally did prior to this. But what we're going to do is we're going to set our device into BGP maintenance mode. So I could drag this over. I'm going to create the change control. I'm going to select what's called a change control template, which is set BGP maintenance mode. And I'm going to select my device after this. In our CloudVision portal, like once you do that, it kind of lets you approve it, pick a device you want to pick, which is the DC1 Leaf 1A. Apply the change control. Review it, because you typically want someone to review it. And this is when the webhook comes in. So at some point when it's finished, it's going to send the webhook over to EDA. So I'm just going to drag this over here because, like I said, it's an internal thing we did that we just kind of chat, the little chat ops, Julio and myself, to talk about this. But once it actually does hit the criteria at the bottom here, if I can get rid of the play bar, it'll kick over to the playbook. So it'll change over to add the Slack portion. It'll also do the portion about ServiceNow with ITSM. And it'll grab the run and configure the device to add us a backup within ITSM. So let me fast forward to that here. If there's any questions, feel free to ask. But you can see here, this is the actual, if you're used to running config, this is the config of the device. It's just kind of doing it in a very verbose fashion as it registers it and uploads it into the ITSM ticket. All right, so once the device actually does finish, we can click on the device so we could see. It might be a little bit hard to see, but kind of highlighting over here with my cursor, but the device itself is in maintenance mode. So that will tell the user, hey, I can't use this device currently. It's not going to really take in traffic, but it's up online for just for management purposes. So once that happens, we can pop over to our ITSM portal. So we're in ServiceNow. We can see here this actually created an automated alert. This alert can look any way you want to, and like I think we talked about this previously, but because EDA has access to kind of like every single Ansible collection, which is like really cool. You don't have to throw away any tools that you do have to get up and started with this. So you could just use the ServiceNow Ansible playbook or Ansible collection that's out there, which is what we did. So we could see here this creates incident. We could see here the description of it has DC1 Leaf 1A is in maintenance mode. And then if we kind of scroll, I'm going to kind of fast forward this here a little bit, we could see a config.txt at the very bottom. So config.txt, once I get to the point where I stop talking in this video, I'm going to open it up here. And we can see config.txt is actually the running config of that device. So it has a good amount of verbosity with that. Also, too, is a link. So let me pause this here for a second. And that link's going to be our CloudVision portal. It could be our SaaS version, or it could be an on-prem version. But with the ITSM ticket comes that portion of it, which once we open that up, we're going to click on it. And it's going to give us certain information about the event that happened and historical events. So like I said, we have all the state data, like of any network device within the network. And we could see here it kind of tells us everything that happened. So you have historical information from that time period, which is very nice. And this is all that kind of happens without a person doing anything, because EDA actually created all this magic all on its own. So we're going to pop over to Slack, and we're going to see here that in Slack, it used the Ansible module for that as well, and it gives us a diagram of the network, and what the network currently looks at that period in time. And you can templatize the whole D2 stuff if you want to. It's actually really cool if anyone wants to talk about that afterward. Julio is heavily into that. It's really, really cool stuff. But yeah, you kind of have everything there. So once you are ready to go and do your maintenance, so let's say you do a code upgrade, you do whatever you need to do, you need to do the whole thing in reverse. So when I say the whole thing in reverse, we're going to have to, at this point, unset BGP. So we're going to go ahead and we're going to create a new change control, because indirectly we're done with our changes we're doing, whether it's a code upgrade or whether it's some kind of, I'll call it sketchy change, but whatever the change you want to do, we want to bring this device out of maintenance mode. So when we bring the device out of maintenance mode, we want to go ahead and we want to close that ticket entirely. We want to tell everyone on Slack, hey, this is done. And this doesn't have to be Slack. This doesn't have to be ITSM. This could be via email. It could be via text message. but it would just be a good way of actually saying, hey, this work is completed and it's over and done with. So EDA is still running, and it's going to wait for the newest webhook. And this demo is actually publicly available on our Arista Networks repo as well, if anyone's very interested in it. But once you do that, you can see the rulebook actually did hit the key items it needs to. The ServiceNow portion comes in. It's going to close the ticket, and it's going to notify Slack that it was finished. Give it a second here. I think the cursor failed me. Maybe, maybe not. Oh. Come on. All right, we can see the device is out of maintenance mode. I think if we go back a little bit, sorry if I'm causing eyes to hurt here. Yeah, we can see the device is actually closed. There's no ITSM ticket, the device is out of maintenance mode, and effectively as well it'll alert Slack and say that the device has been out of maintenance mode and it's good to go on with your daily life here. But yeah, it was overall a good experience with EDA. Like, we generally liked it. We believe in the technology. Just a couple things we're going to just kind of give our feedback and what we liked and everything else about it, and just for other people as well. But any Python async package will just work. So if you have some kind of service in your enterprise that you want to use that uses Python, you could just kind of make it work, and it's an async function. It's very simplistic to get it in the queue and have it work. You can leverage the tooling you have today, so like you're not really throwing anything away. So like if you're using Slack today with the Ansible Slack module, if you're using ITSM through ServiceNow, you can easily use that. You could really trigger off of any event you want to. And in our opinion, it's very easy to get started with this, just because the same YAML infrastructure you're used to using today. Like if you're used to using YAML and linting and so forth, it's just very easy to get started with it. But you could take a look at the collections. Like, they have very good collections that are out there today with things like Kafka, things like the Alert Manager, things like just basic REST server. It's very easy. Now, because we're brutally honest, just some issues we ran into and that I think are fixed already. Only Python async packages work, which I'm not sure where things are changing. I myself generally do most of my development in Go and Rust, so had to put my thinking cap back on for Python, which wasn't terribly difficult, but just to know if you're going through that. It's a little bit of a different syntax, which I think is changing as well. So like things like for item, if you're used to looping, is a thing. And the other thing too is a lack of persistence. I think that's being changed though, right? That's something new that's coming out. So when we did this, a little different. But overall, like we believe in event-driven architecture. We think it's awesome, especially with network events and telemetry and so forth. So that was it. And then anyone have any questions? Yeah.
So I have a general question.
Yeah.
So when I look at the example of the rulebook, it looks like it's based on internet. So if I'm ingesting events from multiple sources,
Yeah.
would I have to build multiple rulebooks per source?
So you can have multiple sources in a single rulebook, and then it just comes down to your conditionals. Every time I've worked with it, I just try to keep it separate, right? Hello? Okay, so when I build, when I do the rulebooks, you can have multiple sources defined. So rulebook can be listening to multiple sources and from there define the conditions and go through all the conditions, just like you can have multiple actions, okay, based on a condition. I prefer to work, and that's just my own thing, with kind of like a rulebook that is flavored for a certain type of event, right? So you could have, for example, a rulebook that's listening to webhooks and send all the webhooks that you're dealing with and push it, to that to that rulebook. The only problem that I see is that's going to eventually start getting a bit sticky, because if you have your conditional sets, we have a thing inside of event-driven called rule sets. So you can build up different rule sets, and you can actually send those events to another rule set. So you might have a rule set for networking telemetry, and you want to send something to that telemetry stack, and then it'll go through those conditions. So you can do that. It does become a little bit more complex. So that's why when I'm doing it, I tend to say, okay, well, this is my Kafka source with this topic that's looking after that. This is the webhook stuff, etc. And obviously, right now we're talking about using Ansible rulebook, but when it comes out with the integration into the platform, the GUI and the interface actually has management of rulebooks, rulebook activation, all of that stuff is there. So it's a lot simpler, right? It's not like you're trying to run all of this stuff in CLI. Yep.
How does event-driven Ansible and rulebooks maintain state running them? So, for example, if that came to be with like multiple sources, so can you do it so that you get like a trigger from source A, determine that you don't do anything, but then you want to get a trigger from source B, you know, hey, I got this trigger from source A, now because these both happened, I want to do this.
Yeah, so what you could do is you could use, you could set a fact, right? So something happens on source A, it goes through the conditional. So you will have an action, but what you'll do is you'll push it through and you'll actually set a fact to say that's been addressed. And then the next time that another event comes through to get to your, condition 1 and condition 2 together to drive some kind of remediation, your condition statement would say, is that fact equal to whatever, and is this new event, has this new event occurred? If it has, then obviously we go and we trigger whatever we need to do.
Follow-up question, like, so the rulebook do not save any variables or anything from all those like triggers.
The event information is handed off. So as an event comes through, if it doesn't get dealt with, it gets dropped. In the integrated version, it keeps a track of all the events that come through. But if it comes through, it doesn't get dealt, it gets dropped. But what we do is event data is handed off. So as soon as an event comes through and it gets matched, it's able to be handed off to a template or to a playbook using Ansible EDA namespace. But this is why we talk about setting facts, because the fact will give you the persistence across board, right? So even if you want to get feedback from the playbook, you go through the process where we set all the facts in terms of what you're specifically looking for. So if you had something go down, and now you have a playbook that needs to now act on that infrastructure. Inside of that playbook, you would then set facts, and those facts would be available back for EDA. So you could have conditions based on those facts. So imagine having a failed state in a playbook because something has happened on a system. EDA can now see that fact and then respond to it. So it's a way that we can introduce the feedback from what you're trying to do. Yep. So are you talking about?
You're talking about something like a back-off timer, or the same event from the same device just got triggered.
Yeah.
Persistence, basically.
We try to notify that on the con. That's something early on we noticed. I'm like, what if that does happen? It's just going to keep executing the same playbook. Now you're just generating a bunch of snow tickets, Slack messages.
The current version's got throttling built in. So you can say that once this event happens, you can say cool down for the next 15 minutes and don't respond to any of those events that are coming from the same event source that is the same event. So at the moment, we already have throttling built in. Yep.
As a piggyback to that, if you have, for example, a remote site where, the head router that goes down, and a bunch of other alerts that are impacted that, right? So that your internal devices also trigger alerts because they're not. Is there a way of
Event
that trigger out where you're not?
event correlation, basically. That is something that we're looking at. So it's on the radar because just like this, for example, let's say you have a number of ports reporting that they're down. You don't want EDA constantly trying to fix the ports. Meanwhile, there's a router that's down in the main office. So that is something that currently is with engineering on the roadmap. Remember, the key thing with event-driven is it's obviously new. We need to see implementations. And from there, we start to see what really is needed and start to add on to that. So there's already stuff on the roadmap, but things like event correlations have already been indicated as something to look at.
Yeah, great question.
So I only have open source, so there might be some lack of knowledge on my part here, but what's the normal behavior for how you actually start the rulebook? Do you like start it on-prem? What do you do when that rulebook gets updated? How do you restart the agent, and how do facts persist or not persist?
So in essence, the way that it should be working is that the rulebook, typically the way that we do is we run a rulebook inside of a container. That container itself has Ansible runner, and it's got obviously Ansible rulebook, and it's basically just listening to those ports. And that's how it works with the integrated platform. So the integrated platform, where we have event-driven controller that's built in, it also listens and it has all the containers. So these containers are what we call decision environments. It's basically an execution environment, but it has Ansible rulebook built into it. So from the interface on the platform, you can control this. But otherwise, what you could be doing, like what we do for our labs, is we build the container, we run the container. And once that triggers, once that rulebook starts, it won't shut down. I mean, it will carry, unless obviously there's like an exception or something like that, but it just runs. So, I mean, you could obviously run or write some kind of script to restart the container or to be aware of that. Maybe you want to get EDA to monitor the other rulebook containers and restart those when those fail. There's lots of things that you could do. The upstream is called EDA server. So you could also mess around with that. That's already open. Yeah. So the event data, once the event data gets processed, it's gone, right? So if event hits and it goes through its action, it's no longer accessible once it's gone through. That's why we set facts to get the old information back into the rulebook. But once you shut down rulebook, then all those persisted, all those facts, etc., are cleared, and you start up again.
I'm curious from Arista, if you guys, are there common use cases, and there's lots of possibilities on how to do this, but are there common use cases that customers or you guys have come up with that here's some real top 3, 5 scenarios?
Yeah, so we developed a framework around configuration. We were thinking about kicking around like a framework developed around this, but remediation was like one thing. We were like, because people don't want automated remediation. But we're open to anything. I mean, this was probably a top request via another customer to do this sort of thing, but we don't have like anything that comes top of mind. But we're open for any suggestions.
Yeah, thank you.
Yeah. Yep.
Yep. Thank you all for attending.
Thanks, everyone.
Appreciate you.
Thank you.
Thanks, guys.
Okay.